Good evening and welcome to the December 2021 edition of Thought Leaders. I'm Dr. Tim Harlan, Executive Vice President and CEO of UTMB Health System. UTMB Health is a proud sponsor of this outstanding programming presented by Space Center Houston. Tonight's lecture explores Starlab, an exciting joint venture among leading aerospace companies to produce the first ever commercial space station. Starlab is a state-of-the-art laboratory for research and commercial development in space. It's a fascinating concept with the potential to impact medicine, agriculture, manufacturing, and nearly every aspect of life on Earth as we know it. I'm excited to learn more. I'm also excited about the upcoming holidays and the opportunity to gather once again with those we love. The chaos of the previous 2 years reminds us that good health is a precious gift. We hope you will take precautions to stay healthy this holiday season as you gather with friends and family, and that you will call on UTMB Health in the coming year if we can assist you with healthcare services. Best wishes from our UTMB Health family to yours for a wonderful holiday and a happy and healthy new year. Thank you for joining us tonight. We hope you enjoy the lecture.
Hello, I'm William T. Harris, President and CEO of Space Center Houston, a dynamic science and space exploration learning destination and nonprofit science center. We also have the privilege of serving as the official visitor center for NASA Johnson Space Center. We share the story of human space exploration, past, present, and future, with more than 1.25 million visitors annually from around the world. Thank you for joining Space Center Houston's Thought Leader Series program, Starlab, a commercial destination in space, presented by the University of Texas Medical Branch. Our Thought Leader Series brings you space and science experts from across the country who provide insights and perspectives on space exploration. Space Center Houston provides robust learning experiences that enable you to be part of the NASA mission. In addition to our extensive collections, we provide new exhibits and live programming, so there's always something new. You can discover how space inspires technological, cultural, and social progress. Currently, you can experience our fall exhibit, Be an Astronaut, now through January 16th. Space Center Houston's Galaxy Lights, presented by Reliant, returns for its third year. See Galaxy Lights transform and illuminate the center with stunning space-themed light installations, watch an incredible kinetic light show, and enjoy s'mores by the fire pit to celebrate the holiday season. Galaxy Lights is an immersive holiday lights tradition, bringing guests the most interactive and technologically advanced light display in Texas, nightly through January 2nd. You may purchase your tickets in advance online at spacecenter.org. This Thought Leader program focuses on the first ever commercial space station that's scheduled to launch this decade. Nanoracks, in collaboration with Voyager Space and Lockheed Martin, has formed a team to develop the space station known as Starlab. It will be a continuously crewed commercial platform dedicated to conducting critical research and fostering industry activity and ensuring continued U.S. leadership in low Earth orbit. Starlab is expected to achieve initial operation capability by 2027. In today's discussion, we'll answer questions about this exciting new space station. So I'm so excited we're going to jump into our program, this Thought Leader Series, Starlab, a commercial destination in space, presented by UTMB. I'm delighted to welcome our panelists, Adrian Majuka, Voyager Vice President for Infrastructure, Eleanor Morgan, Lockheed Martin Systems Engineer, and David Marsh, Nanoracks Strategic Lead for Space Systems. Our first presenter is Adrian Majuka, who serves as the Vice President of Infrastructure for Voyager Space, where he works on cross-portfolio integration and future capability development aligned with making humanity's venture into space permanent. Mangiuca held prior roles at Maiden Space and Nanoracks, where he focused on the design, funding, and execution of plans for the construction of long-duration space platforms. While at Nanoracks, he served as principal investigator for the NASA-funded low Earth orbit commercialization study and worked with 13 partner organizations to ascertain how a future LEO, or low Earth orbit economy, becomes sustainable. David Marsh is the strategic lead for space systems at Nanoracks, where he focuses on long-term planning for space station projects like Starlab and Outpost. Based in Washington, D.C., Dave has been on the Nanoracks team for 2 years. Prior to Nanoracks, he was a strategy consultant with Booz Allen Hamilton, working on a variety of Department of Defense advanced technology development projects in the Middle East, Latin America, and the DC metro area. Our third presenter is Eleanor Morgan, who currently serves as the program manager for Lockheed Martin's space habitation development programs. In this role, she oversees the development and mission architecture for various orbital, surface, and transport spacecraft for low Earth orbit and future expeditions to the Moon and Mars. Ellie's prior industry experience includes conducting human spaceflight research at NASA Johnson Space Center as part of their Human Exploration and Research Analog Program, or HERA. Prior to her space career, she was an active duty combat aviator in the Air Force for 12 years as a C-17 and MQ-1 pilot, and continues to serve today as a major in the Air Force Reserve flying the MQ-9 Reaper. Welcome to all. Our panelists now will provide more information about their backgrounds and the scope of their work, then we'll launch into our conversation. First, we'll hear from Adrian.
Thanks so much, William. It's an honor to be here. Thanks to Space Center Houston. This is an excellent opportunity. It's great to be joined by my colleagues from Nanoracks, a Houston company, and Lockheed Martin. So as William said, my title means that I look over the horizon for new technologies and applications in support of space stations, in particular, those ones that can help people settle the solar system in the future. I also study the space economy. So I try to understand the core business of the future and how we make it self-sustaining. And one of the coolest things that I've ever gotten to do is lead the team that first conceived Starlab, the world's first commercial space station, free flying, in orbit, coming to you in 2027. Fortunately, smarter folks than me are now in charge, engineers and business people with decades of experience, and we're going to make this thing real together. So couldn't be more excited. So Starlab is a space station that is fully complete after one launch. That is so important. The thing about space stations is they usually take a pretty long time to build, and the fact that we can do it in one launch is pretty special. Our current NASA-operated International Space Station is an amazing piece of hardware. It's the biggest thing that we've ever built in space, but it took many governments working together many years to build the whole thing up. It was launch after launch, some assembly required, and we've got a lot of extraordinary capability. It's over 20 years operating on orbit right now, so that's really the pie in the sky goal, but it's hard. The thing about our team is that while we've got a lot of capability, we've also got to run a business, and we need to be careful with our money. So while making sure that we're building the best and safest and most capable space station, we have to limit expensive rocket launches. And we also, at the same time, want to begin hosting astronauts as soon as possible. And these are going to be folks from all around the world, from NASA, commercial industry, from countries all over the world, astronauts that are going to come to us as customers for our services, just like you buy tickets on an airplane, but probably with a bit more training and experience involved for now. So one of the ways that we're going to be able to keep this to one launch and build it when we say we're going to build it is by use of an inflatable module that you can see there on the right that blows up like a balloon. And you're going to hear a lot more about that from Ellie. She's really one of the world's experts on this technology. So we're very, very glad to have her on the team. I can't wait for that part because you get to hear all about how inflatables are the best path for us to get to Mars, a great way to keep astronauts safe from space junk and radiation, and how we're going to be able to fit in so much new technology into that volume, how all of the science and research equipment that you're going to hear more about from Dave is really enabled by that really cool piece of hardware. So can't wait for that. There are a few more pieces of Starlab that you'll hear a little bit about today. The metallic kind of tin can looking thing behind the inflatable module, that's more of a traditional piece of space station hardware, and we use it because we're really good at building those kinds of modules in space, very similar to what's already on the International Space Station today. It's a known quantity. All of our really sensitive equipment that keeps astronauts safe, that gives them air to breathe and water to drink, that's where we're putting that stuff. We've got a big robotic arm that you can see there to bring in spacecraft that want to dock with Starlab, and also to help us see what's on the outside of Starlab and do external activities. In the back there, we have our muscle. It's called a power and propulsion element, and it provides, you guessed it, power, about 65 kilowatts of it. The ISS, by the way, has just over 100, so we're doing pretty good. And it provides propulsion to keep us on orbit, in a stable orbit. And these systems, and a few more, it's pretty complex, make Starlab into a one-launch space station that on day one will already be about a third the size of the ISS and host as much science equipment as is on the ISS today. And of course, we can grow it with other modules if we want to. You can see in the front there, we've got a docking node for that. We can assemble a bigger station, but I'm here to talk to you about what we do on day one. And that's really what makes this different. And it's in that science equipment that I want to dig in a little bit more, because that's really the heart and soul of Starlab. That's what I want to focus on today. Inside Starlab, inside that inflatable, something really special. I'm excited to share it. We call it the George Washington Carver Science Park. And George Washington Carver, aside from being one of America's most important scientists at the turn of the 20th century, was a great agriculturalist and agronomist. He was a professor at the Tuskegee Institute and a source of inspiration for millions of people. And including myself, including our team, truly. It's in his honor that we've named the science park inside Starlab the GWC. What's cool about science parks is that we have them on Earth today. They're a place where people can share all kinds of science and engineering ideas. They're accelerators of innovation. They're places where inspiration flows freely and business gets done. In short, they're a business model that we know a lot about. It made sense for us to put one in space because we knew people would want to do business there. And speaking of business models, I have to say that Nanoracks knows what they're doing in space. Obviously, so does Lockheed. But what's cool about Nanoracks leading this team is that they've already flown payloads from every state in the United States. They're a Houston company that flew lots of Houston payloads. And when I say payloads, I'm talking experiments. I'm talking satellites flung off the ISS. I'm talking agricultural science, engineering science, the coolest stuff you can imagine. I encourage you to read a little bit more about it. 1,300 payloads in just over 10 years to the International Space Station and beyond. So these guys know what it takes to do science in space, to operate not only a space station, but the GWC Science Park. And you might notice that we're being really specific about science, and this is important because that's intentional. By naming it the GWC Science Park, we dedicate ourselves to scientific pursuit for the purpose not just of the exploration of space, but for the betterment of life on Earth, just like George Washington Carver himself. He improved the lives of poor farmers by discovering new strains of sweet potatoes, by discovering new uses of peanuts, peanut butter. You might know peanut butter. Well, you can thank George Washington Carver for that. And he made this stuff easier to grow, just so people from all over the United States, all over the world, maybe even you, will make discoveries on agriculture, engineering, and physics on Starlab, and that's really what drives us. That's our motivating force. So we imagine a world where Starlab focuses on science. Tourism's great, but on our pathway to make space a place where everybody can see themselves, for every researcher, student, explorer, worker, for the prosperity and benefit of all people, all Americans, all people all over the world. We're focused on science in this first round, and we'll grow beyond that. But here we are today. And I'd love for Dave to talk a little bit more about the GWC Science Park, so you can really learn what it is that's behind it all. So thank you.
Sure thing. Thank you, Adrian, and William, and the rest of the Space Center Houston team. Thank you for having us today. We're all very excited. We've been working on this for a long time, and we're very eager to talk about it and show the world what we're working on. So as Adrian mentioned, Nanoracks has been doing this space business for a long time. He said 1,300 payloads from every state. I think the number is also about 40 countries, 40 or more countries. And along this history, we've learned what it takes to fly a payload. to conduct science on the ISS, to deploy CubeSats. And my role at Nanoracks is to take that decade of knowledge and distill it into a strategy for how we conduct science in the future. Not only how do we make that a viable business, but how do we make it more accessible for students? How do we make it easier for researchers who don't typically work in the space environment to move their research to the microgravity space? And then how do we take that and apply it to future technology development to help work on getting humanity to Mars and beyond? Some of the things that Ellie will talk about a little bit later. So as Adrian mentioned, the George Washington Carver Science Park is the core of Starlab, and it's going to host the scientific capabilities necessary to not only meet NASA's objectives moving into the future, but also meet the objectives of commercial companies, of researchers, and of students. The way we're going to do that is by having laboratory capabilities in a number of different areas to start with, but then also include a process that allows us to modify that laboratory structure as requirements change. So the initial capabilities will include biology, plant habitation, physical sciences, and materials research capabilities. Many of these are areas that are already conducted on the ISS today. We're going to take those and we're going to add a open workbench area where astronauts can modify payloads, host their other equipment that they need to go about their daily lives, and conduct other modifications as necessary to the equipment. We're also going to have what we call unconfigured volume, or basically available volume that other researchers, universities, associations, commercial companies, whoever can use to put their own payloads. So you can either use the components that we put up there for you to use, which are going to be some of the most technologically advanced scientific hardware in the world, or you can put your own capabilities up there. And we think the combination of these two is going to be really important for allowing researchers to respond to changing science and requirements. The way we're going to go about those modifications is something we've designed called the user needs-based design process. Basically, all that means is we're going to take the input from the entire scientific and microgravity research community, including students, and we're going to take that and distill it into how we need to change the hardware we're starting with. So we have an initial plan, and that's based off of the work we've done with our partners that I'll talk about here in a second, and the over a decade of research that Nanoracks has helped facilitate on ISS, and we're going to adjust that as necessary going forward. The first launch for Starlab is going to be in 2027. The only launch for Starlab will be in 2027. But going forward, we can bring new hardware to the station, we can modify old hardware, and we can really respond to changing requirements. So here you can see a breakdown for the George Washington Carver Science Park team. Nanoracks will be the owner and operator, Voyager will provide the strategic input, and Lockheed will be the primary spacecraft integrators. But then within the GWC Park, we'll have USRA, University Space Research Association, who will manage the park. They'll prioritize the research, they'll do all the scheduling, they'll run some of the business development aspects, making sure that there's a pipeline of research coming into the station and that the research is being conducted on Starlab gets published and can be reproduced in different environments. We're also going to work with the Ohio State University, who will manage the university consortium. So they're going to have a wide network of universities who are funneling their research to station. They're going to be coordinating some efforts with some government groups, with NASA, and they're also going to be managing our terrestrial analog facilities. So Starlab is not just going to be in space. We're also going to have some ground stations where we can model our research, where students can come and walk through an actual model of the station, where a researcher can go and design their experiments specifically for hardware that's going to replicate exactly what's in space. And we think that's really important, not only for researchers conducting their research more efficiently, but also for students and the general public to really get a feel for what's going on. We're also going to work with the International Association of Science Parks. This is an organization of over 600 science and industrial parks worldwide, and we're already a member of this organization. The George Washington Carver Science Park exists today, and it's a member, and I'll talk in a couple minutes about what that really means. IASP is going to help us coordinate with researchers around the world. This is not just going to be a station for American researchers, but a station for anyone who wants to conduct experiments in microgravity. We're also going to work with a company called Zinn Technologies. Zinn is perhaps the leading hardware development company for microgravity research. They've developed a whole suite of equipment that's on ISS today. including some of the most critical pieces of hardware, such as a glove box facility. It's where the astronauts stick their arms in and play around with the experiment, as well as a microscope. We're going to take Zin's expertise and also develop a new way of conducting logistics in space. So the way that you move payloads around is going to change a little bit, and it's going to make it easier for us to modify hardware going forward. So really excited for that work there. Last but not least, we're going to be working with DreamUp. DreamUp is a public benefit corporation affiliated with Nanoracks who runs student programs, STEM campaigns, allows students to do programming experiments on ISS, a whole suite of activities. And they're going to work very closely with OSU to coordinate student activities, whether it's competitions, projects, or even just gathering student input for experiments that we want to have on Starlab, experiments that we want to conduct, activities that they would like to see. So we're excited for that collaboration, and STEM education is certainly a focus for our project. One last note on this slide, collectively, this group has over a dozen Space Act agreements with NASA. We've all been doing this a long time. We know the requirements that it takes. We know how to work with NASA. We've built partnerships with NASA over a decade, and we're very excited to continue that partnership into the future with Starlab. So as I mentioned before, the George Washington Carver Science Park exists right now, today. We're a member of the International Association of Science Parks, and researchers can conduct their science as a part of the GWC Park. Nanoracks owns and operates some hardware on ISS today, most notably the Bishop Airlock, which is the first private real estate on ISS that we launched in January of this year. And this allows us to deploy payloads, access the space environment, host activities, things of that sort. We even use it to throw the trash off of ISS. So it has a number of use cases, but this is an area where researchers can conduct experiments today. Nanoracks has other hardware on station, including something we call the NREP, Nanoracks External Platform, and the NRCSD, Nanoracks CubeSat Deployer. And basically those two things host payloads outside the ISS. So for example, some experiments need to be exposed to the actual space environment rather than being held in the internal pressurized volume of ISS. And the external platform allows us to do that, while the CubeSat deployer allows the astronauts to basically load CubeSats and then deploy them off of the station. So we're going to take all of these capabilities, including some other microgravity science components that we operate, like a microscope, like a DNA sequencer, and a microplate hotel. So if you think of science experiments, there's often those little tubes, liquids gets pipetted into, The microplate hotel is a place to put those, a place to keep them at a certain temperature or modify them as necessary. All of these components are now bundled as the George Washington Carver Science Park. That means that there's going to be different ways that researchers can access funding, but more importantly, it's going to allow researchers to start working with us to plan for the future. You may be conducting an experiment in space today, but we can start planning for what the next 3 or 4 or 5 evolutions of that experiment look like. Perhaps how you commercialize that experiment, perhaps how you modify it to incorporate some student researchers as well. By working with Nanoracks and the GWC Park on ISS, we can build that transition into the project that we're working on. So that's a little bit more granular on the scientific capabilities of Starlab, but we're not limiting ourselves to just the science. Science is key. NASA is going to be our core customer, but there are also reasons to include commercial volume in Starlab and the GWC Park. Things like additive manufacturing, things like 3D printing organs, things that are right on the cutting edge of technological capabilities that other companies are trying to commercialize and trying to make businesses out of. There will be volume on Starlab for those customers to conduct those activities. There's also going to be space on there for experiments that we don't know are going to happen yet. For example, NASA's looking at taking us back to the moon and eventually to Mars. There are going to be a number of technologies necessary for that journey that we need to develop today. So there will be volume allocated to GWC for test beds for those equipment. Anything that NASA needs to test, such as life support systems, such as a separating part of the station for a long time to allow for what it really would be like if you were traveling for 8 months through space and what the physiological effects of that journey would be. Starlab is going to have the capabilities to facilitate all of those. So with that, I will pass it over to Ellie.
Great, thank you so much, Dave and Adrian. Really excited to be with you all here today, and thank you, William, and the Space Center Houston team as well for having us here to talk about this really exciting project. So my name's Ellie Morgan, and I work for Lockheed Martin, and my role is I've had the distinct privilege and honor this year of leading the Lockheed Martin team in our proposal effort and now moving forward as we begin our development on the station. We're thrilled to have amazing teammates such as Nanoracks and Voyager Space, and I think as many of you know, teamwork makes the dream work, and that is one thing that we are really proud of, is how great our teams have worked together, and we're excited to make this dream a reality here soon. So what I want to talk about with you is Lockheed Martin's role. We're going to talk a little bit about inflatable technology with habitats, and then really, how this all fits into the larger picture of, why does this matter to you? And what does this mean for humanity in the future? So Starlab. Now, essentially, this is really going to enable the foundational architecture for us to do a building block approach that will ultimately take humans back to the moon and then onward to Mars. Now, Lockheed Martin's role, in this project, as was mentioned, we are the spacecraft integration and technical lead, and we're also developing the habitat portion of the spacecraft as well for the station. So here we have Starlab in low Earth orbit, and this is really important because it's going to enable us to free up NASA to now focus their efforts and money on getting humans back to the moon and then onward to Mars. As you can see in this picture here, the inflatable habitat portion of the spacecraft, that is really the foundational architecture now, and that inflatable habitat is going to enable us to bring a lot more volume for less mass. And that becomes more and more important as we use rockets to bring us further and further away from Earth. So just kind of think about it as, much more fuel that you would need. And what we're going to do, as Dave mentioned, is this also gives us the ability to test this out in low Earth orbit. And then we can also, down the road, we have the opportunity to maybe even run some analogs in low Earth orbit to test this out, with folks pretending that they're going on a trip to Mars. And we can learn a lot more about this and make things more safe before we send humans out that far. Now, as I mentioned, that inflatable architecture, that's going to be used not only in low Earth orbit, but we're also going to use it in areas around the moon. There's going to be architectures that are going to be orbiting the moon. Some of you may have heard of as NASA Gateway. Inflatable architecture is going to be very important also for surface habitation on the moon, as you can see in one of the images here as a concept. And through the use of Lockheed Martin's Orion spacecraft, we're going to get folks back to the moon. And then we're going to shift our focus and we're going to look towards Mars. This is one of the recent concepts that Lockheed Martin has been working on. It's called Mars Base Camp. And as you can see in the middle, this also utilizes inflatable architecture for a habitat in the center of the spacecraft, while also utilizing nuclear thermal propulsion. This will be a key part of the spacecraft that brings the first woman and man out to Mars, and we're really excited for that. And one of the other things I just want to talk about as well, as Dave and Adrian touched on, one of the other really important facts about inflatable architecture is that, especially in low Earth orbit, as we have seen more and more orbital debris that's getting generated, that's actually going to keep our astronauts safer. We'll be running a lot of orbital debris assessment analysis, to determine where is the right place to put the spacecraft. And when it comes to inflatable structure, a lot of times people think of this as almost, a balloon, and they think it's going to pop. But actually, I would explain that an inflatable structure, you have an inner, you can call it a balloon, but it's surrounded by much stronger layers. Kind of think about an onion, and you can peel away all the layers before you get to the middle. Now, those outer layers of the inflatable habitat, those have shielding. So kind of think of like a bulletproof vest. And so if a piece of debris were to hit that, there's several layers that are put in place, so it absorbs the impact of any debris that comes into contact with the outside, slows it down, and keeps it, on the outside of the spacecraft, before it can pierce the inside. So in many ways, as we look ahead in the future with orbital debris, inflatable structures, can also serve to be more safe than traditional aluminum modules on space stations. And with that, I also just kind of want to close by saying that, Lockheed Martin, we're really excited to be part of this team. And we are excited to bring all of our knowledge and experience from not only our Orion spacecraft program, but also I think not many folks are aware that Lockheed Martin has actually built spacecraft that have traveled to every planet in our solar system, to include asteroids and then also beyond Pluto. And we've also built more spacecraft than any other companies combined to go to these planets. And what's really exciting is that of the 5 spacecraft that have traveled to Mars, Lockheed Martin has built 4 of them. And the one that just landed this year, that many of you are probably aware of, we actually built the aeroshell for that. So we have a long history and heritage of building spacecraft and exploring new worlds. So we're excited to do that with Starlab and lay the foundation for humanity to get back out into the stars. Thank you.
Wow, thank you so much, Adrian, Dave, and Ellie. That was absolutely fascinating. I have so many questions for you, and this is so exciting to look at this new technology. And we actually have this great history, right, of building on those who've come before. Of course, we had Mir, we've had Starlab, and now we have the ISS. And of course, this is kind of the newest technology. I was really fascinated to hear that it's inflatable and that actually it's going to be 1/3 the size of the space station. So just to clarify, we'll have a capacity for 4 astronauts or 4 researchers, right, is the capabilities. I'm trying to get a sense of the scale, again, the actual habitat module with 4 people inside, so it's got to be pretty big. Will it have all of the features or improved upon features that you would find in the ISS lab?
Yeah, I'll take that, and maybe Dave wants to talk a little bit about how we determine what those features actually are. But as I said, science is so important to us, and responding to the needs of the scientists of the future is really important to us. So we're not deciding today what exact equipment is going to be on there. We're keeping that flexible. We'll come to a decision in time after lots of consultations with real researchers all over the world, because they know better than we do what they need to conduct their research. We want to talk to them. That's kind of thing one. Thing two, you can see scale here. Starlab is pretty big. It's pretty roomy on the inside. A lot of that room is taken up by that scientific equipment, which is why we're so focused on making sure that we get the right training, the right folks with the right stuff, doing science, doing doing research for their countries or their companies or their local space agencies, NASA or otherwise. That's really kind of where we're focused. Another key design feature of that inflatable is that we plan to launch it fully outfitted with that scientific equipment on board. So that's what I mean when I say it's fully functional on day one. That's incredibly important, not only to our customers, but really to our business model, so we can begin generating that revenue and generating that research immediately. That capability is critical because, again, we don't want to pay for that second, third, and fourth outfitting flight if we don't have to. If we can install everything as much as possible on the ground. Maybe Dave, you want to talk a little bit about the process for how we determine what we want to put up?
Yeah, absolutely. And just to start with, so if we assume that we need to host 4 astronauts continuously, there's a number of facilities that we're going to need just so that they can survive. Right? They're going to need an area to sleep. They're going to need an area to eat. And so that's kind of the first section of volume that we determined. Then we looked at how much volume do we realistically need to be able to perform the science that we need to support NASA's goals moving into the future. This will be a location primarily for NASA to complete their scientific objectives. And so we needed to make sure that we can fit that hardware as well. Then we looked at kind of general areas of science rather than specific components. So we know that biological research and plant habitation is going to be an area of focus in the future, not only for Nanoracks and for commercial companies, but also for NASA. So then we looked at kind of generally what capabilities we would need to support that rather than specific components. We're going to work very closely with Zinn Technologies to figure out exactly what those components are and what they're going to look like, and then build a pathway into them so that we can change them in the future. Just to give you an idea of comparison in terms of what this volume means compared to the ISS, Starlab is going to be about 30% of the utilization volume of ISS in that first launch. So if you imagine the internal volume of ISS where people can conduct science, we're going to have 30% of that in our first launch. There's going to be a pathway for us to build to more volume, and we have some other space on station that hasn't been allocated to certain research areas yet that we can modify as necessary.
That is so exciting. When I know we have benefited from Nanoracks because we actually have an experiment on ISS that is on your platform, and we use that with our youth programs. And so it's exciting to know this is going to be a platform that anyone can participate in, because space is the great frontier. It excites people all over the earth or from around the world, and they want to find a way to participate. Have you begun thinking about, I imagine you're going to be overwhelmed with requests for people who want to participate and go up. Are you getting to think through that process, how you're going to develop the priorities so that you can, and then of course people have to go through some kind of training. What kind of training are you thinking about for, say, X person who works at X company who wants to do an experiment for a week on Starlab?
Sure, I'll jump in there, and then if you guys want to add, feel free. And first off, William, I can't tell you how many emails I've gotten from people reaching out who are interested in participating in Starlab, but that's a good thing. That's what we want. We want everybody to come to us and tell us, what do you want to do in space? What research are you working on? Even if it has nothing to do with the space environment, can we find a way to take that research and apply it to space and find some new advantage there that no one's thought of before? Whether it's taking seeds up there to expose them to radiation so that they can benefit life on Earth by being more resistant to drought, which is a use case that we've actively been exploring with some of our partners. Our goal is to just take all of that feedback, take everything we can find, and then use it to shape our way forward. That being said, there will be some training and shaping that needs to happen. Primarily, we're going to be focused on NASA astronauts in the near term, but then there will be a pathway for commercial astronauts in the future. We're still determining exactly what those training regimens will look like, but that is something we're exploring. Adrian mentioned space tourism a little bit earlier. That's something that we can support, but that's not the core function of Starlab. The core function is to provide that scientific research capability, but then we can explore any of these other things that we need to do.
Yeah.
So I'm sorry. I wanted to, if I could just jump in with a question around, everyone's going to ask, where's your mission control going to be? Because we have such ownership in Houston, right? Around from here is where we have managed human spaceflight missions, but now with the private sector, those mission controls could be in other locations.
Our mission control facility is called The Bridge, and it's going to be located in Nanoracks Houston office. We're trying to build, a space station here. We're going to need the brightest minds. We're going to need the hardest working engineers and scientists to make this a reality. And Houston is going to be the center of that. So that the team will definitely grow. Adrian,
I think you had a comment as well.
Oh, no, that was just to say, Nanoracks has been training, civilian researchers, student researchers, professional astronauts, space agencies on utilizing space station hardware for a decade now. So, Nanoracks is really ready to take on the challenge of training folks to do science in space. Maybe not themselves, maybe they won't be the ones going up there, but certainly there will be astronauts up there, and maybe someday even robots, to do that research for those scientists and get them the data that they need back. Now, I will also say that there are some really good science programs or training programs out there that exist. We're exploring leveraging those training programs for true astronauts that spend time on Starlab, months at a time potentially, doing their research for their companies, for their space agencies, for the nations. That's a different training program entirely, and we're really glad to have partners like Lockheed Martin that have so much experience, not only in that area, but in really controlling the operations of highly complex spacecraft. So on the training and on the mission control side, having them on our team has been absolutely invaluable. Don't know if Ellie wanted to add something on mission control, but
Sure. Yeah, as Adrian mentioned, we also have mission control centers, and we have a lot of experience in running that for all of our interplanetary spacecraft that we have. So that's another great resource that we're able to also provide. And, also just kind of circle back, I think as many folks are already aware, we also have a Houston office as well. We have myself, I'm in Denver at our Lockheed Martin Space headquarters. But we also, we'll be spread out, doing a lot of the design work in Denver. We'll probably be also doing some work in our Houston office with folks there, because that's a great resource for us, being co-located, with Johnson Space Center and getting all of that insight, and then along with our Nanoracks counterparts there too. And then probably some other areas as well where we will be doing some of the manufacturing. So yeah, so we're really excited to be part of this.
So Ellie, I think my next question is probably to you, and that is, we've had a program recently, a thought leader program, about kind of the 5 ways that space can kill you, right? And one of those is radiation. It's a big issue as we prepare to send people outside of the protective environment of Earth. And so I'm really intrigued how this structure might provide perhaps greater protection for astronauts from radiation. Are there features that help provide that kind of protection?
Yeah, no, that's a great question. And it is. I mean, that's one of the big showstoppers that we've been struggling with in terms of, there's a couple, but getting folks outside of low Earth orbit. So I think one of the things that the Starlab, the opportunity that that's going to give us is really more of a deep dive to look into more of the radiation and how can we combat that and how can we mitigate the effects of that by studying it in low Earth orbit, and then also with some of the concepts and designs that we are looking to, put cislunar or on the surface of the moon. That once we're outside of low Earth orbit, that will help us also get a lot of data points. And I'm not sure if most folks are aware, but our first Orion flight that's going to be going here soon, Artemis 1, there's a radiation experiment that is going to be going on that flight. And I think you guys have had a previous Thought Leader series on STEMRAD. So yes, that's going to be really helpful for us. Lockheed Martin's also involved in that project with Oren and his team there. So we're really going to take some of those data points and be looking into, what can we put on not only the outside layers of the inflatable habitat, material that we use for the protection from space debris, but having the extra volume that also enables us to put more mass and more equipment also around the wall space inside in terms of radiation protection. So, greater volume also gives you more ability, either inside or outside. So yeah, that is definitely going to be one of the hot topics that we will be getting focused on underway here soon.
I think it's one of the great challenges as we send humans further into space, with a return to the moon, especially because the goal of NASA, right, is to have a long-term presence on the South Pole, and those astronauts are going to be exposed. It's not like the Apollo missions; those are very short, relatively, right? They were, you were only on the lunar surface for most of those missions for up to a few days. Mm-hmm. And so that's a really vexing question that I'm sure we're going to figure it out. So this is exciting that you're going to take a step in helping to address that.
Definitely. Well, and I think it'll really be a multi-pronged approach, and it'll depend on where the habitat is, if it's orbital or surface, and maybe people will have their own shielding they'll wear at certain times, but then, also go into the structure. And then maybe we use outside elements to provide additional shielding, such as lunar regolith, on the surface of the moon, and there's other options. So yeah, it'll be, we're ready to tackle that challenge.
So exciting. I was curious about the kind of training, because it's, we've got many years of sending people into space. It's great. We have a 20-year history of humans living on the ISS. And now we're moving into this really interesting era of time with space tourism. And we're beginning to see not only people having brief experiences, going into low Earth orbit for a short period of time, but, orbiting the Earth, or now their missions planned for a few days for people who are not going through the whole rigor of an entire astronaut training program. Have you begun thinking about what are some of the essential elements of things you need to teach people to go into space? I know at Johnson Space Center, they have training facilities, and you have to teach people basic things like how to go to the bathroom, how to eat, how to sleep, these things that are essential to our well-being as living organisms. Are you beginning to plan for that for Starlab?
Yeah, so the team, we are already, as in the beginning right now. That's a really important part of it, is the mission and the ground operations and the training. So that is also an area that we're going to be working on along with Voyager and Nanoracks. But luckily we do have some experience with that as well. So we will be looking into that and hopefully trying to leverage, some work with NASA as well. And now there's a lot of private companies that are coming into the fold that are going to be offering training. And I'm not sure if many folks are aware, but we're excited that one of the inspiration for astronauts was actually a Lockheed Martin employee. So, we'll be leveraging all kinds of experience and getting those training programs together.
Fantastic. I'm really fascinated by this because a lot of people don't realize that we here on Earth are the greatest beneficiaries of space exploration. There's so many innovations. And are you thinking about how this is going to be an economic influence, not only in the US, but internationally, as you're planning and doing your kind of modeling? Because I imagine it could be a great stimulus for industry and for innovation.
Yeah, I'll start with that. I'm sure the team has thoughts, but I want to remind everybody listening that every time humanity has lifted the veil of the unknown and done science, done exploration for the sake of doing the exploration, right, with no particular end goal in mind, we've discovered things that have fundamentally changed the way of life on Earth, that have changed our economy. It's because a few crazy scientists decided to look into the atom. It's because a few crazy folks, some of them at JSC, thought that humans should land on the moon. That we have our cell phones, that we have energy to light and warm our homes. That we have radiation therapies that can help cure cancer and fight the diseases of today and make human suffering history, that can generate prosperity. They weren't thinking about building Google or Facebook or Instagram or Netflix when Tim Berners-Lee was at CERN in Switzerland dreaming up the internet. That wasn't the goal. They didn't know what the goal was. The goal was maybe share data between a couple of universities across the country a little bit faster than doing it by snail mail, which, by the way, is a thing that I remember. So it's a good question, but I want to start by saying that I have some specific ideas, right? That's my job. My job as you could say part of my title is space economist, right, or space business modeler. Part of my job is to figure out what is the concrete stuff we can do right now that makes this a sustainable business. And I'm telling you that I and our team have the utmost confidence that there are enough astronauts out there, enough aspiring astronauts out there, enough science to be done, enough work and industrialization to do, that Starlab, not only in and of itself, is going to be a self-sustaining business model, but there's room for other space stations in other orbits, or even the same orbit. It doesn't matter. There's room for more than one space station, period, full stop. There is enough demand out there. We can get into the business model. I'd be happy to. It's my job. You can go online and read the LEO commercialization study for free. It's on Nanoracks' website right now. We released it publicly. But the shape that I want to give this conversation is just to say that research for the sake of research, exploration for the sake of exploration, will yield benefits in 10, 20 years, within all of our lifetimes, that we cannot possibly foresee today. And it is with that confidence that we move forward into this new era of space stations and exploration and crewed space flight, because we know those discoveries are just around the corner, and we want to be the team that enables them for all humankind.
And if I may just add on to that, in addition to those economic and technological benefits that we can't possibly predict, but we can know will be there, there's also an intangible piece here as well. Being able to inspire the next generation of researchers, of scientists, of explorers. You can't possibly put a value on that. And I think that's why we've all gotten into this business in the first place, right? Because it's so fascinating, because we were inspired by people who came before us. We want to continue that tradition. And so that's another benefit to going out to try and live amongst the stars, and Starlab hopes to contribute its own little piece to that as well.
Well, all I can say is hooray, because I'm a scientist and I celebrate basic science. And so often, unfortunately, we're in a period of time where everyone wants like the direct result. And yes, of course, we want results to come out of it, but some of the most incredible and impactful benefits of science have come out of things that were unintended consequences, right? Things that we have learned. And it is amazing. We're living in a time, and it seems like we are exponentially accelerating with new insights and innovations. And one has to really be kind of nimble and resilient. So I really applaud you all for having that perspective and moving forward with something so innovative. I just want to go back to a couple little practical questions. Will we be able to see Starlab from Earth when we look up in the sky, like we can see ISS? Will it be traveling at, I presume, more or less at the same velocity to maintain its attitude, right? About 17,000 miles per hour.
That's right. So that's a great question. One of the coolest things that I ever saw when Bob and Doug went up on the first crewed space flight was I looked up and the ISS happened to be going over that evening, and me and my friends, I said, hey, the ISS is going out, and earlier today there was the first crewed launch from U.S. soil in over a decade. My goodness, like what if we saw the Dragon right behind the space station? And sure enough, there were two stars shooting across the sky, one big one, and I knew that was the ISS because I've got the app, and one tiny little one following just behind it, ready to dock. It's one of the coolest things I've ever seen. But as you saw maybe on that comparison chart a little bit earlier, Starlab is a bit bigger, and we will be able to see it across the sky, moving maybe 17,500 miles an hour, just like the ISS. Maybe a little slower because we're at a higher altitude, maybe a little faster because we're lower. But we'll see what orbit and inclination we end up in. But one thing I'm pretty confident about is that it'll be flying over the United States pretty regularly. So I can't wait for folks to enjoy that new addition to our sky. Can't wait to see it.
I have to just tag on, Adrian. I was at that launch in Florida and saw the ISS flying overhead with that launch, and it was so powerful for everyone, on the coast. It was an amazing coincidence, and it really was portended for the future of space exploration, right? And the advancement, I think, of the private sector and the things they're able to advance and do. And they've always been part of this the space program, as we've of course heard from Ellie, and the history and legacy of Lockheed Martin and other companies. But it was really an important moment because it really did symbolize a transition, a new phase, right? And how we're approaching space exploration and the space economy, which is really quite remarkable. I wanted to go back to some of the research that will be happening potentially on Starlab. And it is so exciting. We've had a number of thought leader programs where we've talked about growing human organs in space. Of course, the Astrorad vest, to protect humans from radiation, and just the amount of innovation is quite remarkable. What are some of your aspirations for things that are insights? I know this is a tough question because there's so many things that you could select, but are there a couple of things that really stand out to you that you hope will be a focus of research that will take place on Starlab?
Yeah, absolutely. Two ones that jump out to me. The first, and I mentioned this a little bit earlier, is the agricultural research, the ag tech. Not only because it possibly has one of the greatest influences on life back on Earth, whether it's developing new crop strains, more efficient ways of growing crops in greenhouses, things like that, but also because it has an impact on future exploration, using plants to provide oxygen for astronauts as they travel to Mars, eventually growing crops on different surfaces, the lunar surface, on Mars, in a space station somewhere. So I think that one's very interesting to me on a personal level, as well as just kind of from a commercial standpoint. There are a lot of companies and researchers looking at it, so it makes sense from a commercial use case as well. And then the second one that's really interesting to me ties in with some of the other research that Ellie was talking about, which is the physiological research. having more people in space for longer amounts of time just gives us more data to understand what it means to live in space for a long amount of time. And so this one may not have as much of a commercial use case, but it matters a lot more to humanity and matters a lot more to our future exploration goals. And so that's an objective that NASA has demonstrated as one of their focus areas scientifically over the next decade. So personally, I would say that those two are my most interesting, but I'm happy to open it up to others.
Yeah, I'll just piggyback on that. Yeah, probably more along the lines of what Dave was talking about with regards to benefits for the exploration side of it. You know, a lot of folks don't think about this part as much, but a lot of study needs to go into whenever you have a new spacecraft. You know, how are those systems going to perform? How many spares are we going to have to bring with us on a mission to Mars? You know, what does that maintenance look like on the systems? What are the logistics we will need? How much food? So there's a lot of those things that have to get figured out. You know, and a lot of that's different than how we've been operating on the ISS in many ways. We get like constant resupply missions coming and going, right? We won't have that on a journey beyond low Earth orbit. So I know for us at Lockheed, as we look forward, you know, look out towards the moon and Mars, that's going to be some really important data points that we hope to acquire over the years, especially if at some point down the road, we focus on doing more of the exploration analog portion of this.
And how about for you, Adrian?
Yeah, I guess I'll jump in too. Ellie kind of took my answer. I'm really interested in crewed human space flight and how we get humans out there. I mean, as you kind of implied earlier, space is a rough place to live. Everything is working against you at all times, but we know that the most incredible innovations are forged in the fires of adversity. And I'm highly confident that because of the difficulty of keeping folks alive and comfortable on orbit, we're going to discover ways to keep them healthier, happier, safer, better off, more prosperous on Earth. It's because we forced ourselves into those challenging environments that we really learn that we really learn what we need to. I mean, think about it. Your best teacher, looking back on your education, college, high school, elementary school, probably wasn't your easiest teacher. It was your hardest teacher. The ones that challenged you to be better, to work harder, to really sweat and to think through the problem. And that is why space is so special. And that's why I think it's so important to send people up there. It is that challenge that makes us think. It is that challenge that makes us better. It's that challenge that forces us to innovate. Sending robots is great. It's great. And we should continue doing that. Absolutely. But people are the special ingredient. And yeah, I just want to agree very forcefully with what Ellie said there.
No, it is really fascinating, the interaction between humans and robots, because a robot, I don't think ever will be able to replicate what a human can do in terms of responding to a particular scenario or situation, or, I mean, we're really quite remarkable organisms, right? The things that we can consider and think of and process. I'm curious, I want to go back to one of the dangers in space, and this is something that I think isn't everyone's thinking because we've heard about near misses in the recent years, but space junk. You know, increasingly there are volumes of things in space, and when other nations blow things up, it creates thousands of pieces of space debris. What kind of mechanisms are you anticipating having in place to help protect Starlab from space junk or other objects? You know, of course, there are asteroids cruising through space and other kinds of debris from the Big Bang still. So what kind of mechanisms are you anticipating having in place to help protect the vehicle?
That's an Ellie question.
Yeah, no worries. I can hop in here a little bit. You know, I kind of touched a little bit before about some of the space debris, but, you know, I think a big part of it when we're in low Earth orbit, right, we have entities that are trying to track the debris, you know, but as we get more and more debris, that gets really hard to track. And when the debris gets smaller and smaller, that's also harder to track. So obviously we'll be using that data. As I mentioned, you know, we'll be looking in terms of, you know, what is the inclination, you know, of the orbit, what is the altitude, what makes sense, you know, what portions, the forward-leading portions of the spacecraft will be vulnerable to more space debris. You know, that'll be an area where we'll be sure to kind of beef up our the armor, if you will. of the outside of the spacecraft. And also, with any spacecraft, we're working on, having redundant systems and really looking at what else, if something were to go wrong, what are the alternate options for folks? Luckily, we're in low Earth orbit. If there was ever to be something catastrophic, which there, who knows, there's always a danger. Luckily, we will always have a vehicle docked to the station at all times with astronauts, so they will have an escape pod at any time should something go awry at the station. But obviously, we're going to work very hard to keep that from happening, and we're going to be ensuring that a lot of tests are put into place. There's things such as hypervelocity tests that we'll be doing against different types of material to determine, how many layers of material and what type of material and where it's placed around the outside of the habitat module. So that will all kind of go into play there with that.
I also want to touch a little bit on that muscle we have in the back of Starlab, that power and propulsion element that really gives us the kick we need to get out of the way of any dangerous debris as we collaborate closely with our friends on the ground and in space that are tracking that debris. They can track pretty small debris by this point. Gives us the ability to maneuver pretty rapidly should we detect anything dangerous incoming. So it's worth mentioning that.
And just one final thing to add on the debris piece, Nanoracks is actively working to provide solutions to the debris problem, not just with Starlab, but through other programs. We're actually going to be flying a tech demonstration mission later next year that's going to that's going to demonstrate the capability to actually cut or potentially recycle, disassemble debris in orbit. So this technology could be used to take large rocket bodies that are just up there as debris and disassemble them or use them for other purposes. So we're working with the entire space ecosystem to figure out solutions to this debris problem, some creative ones as well. And our goal is to work with them to make sure that we're solving this problem for future generations, as well as for protecting Starlab once it's operational.
That is absolutely fascinating about being able to repurpose it. I mean, this could be like a whole other thought leader program to talk about that.
Next episode.
Yeah, exactly. It's absolutely, it's a huge issue. And I think that is so intriguing to think about repurposing, because right now it just floats up there or it burns up somewhat, right? Coming back into Earth's atmosphere. So that's absolutely fascinating. I'm wondering, would all of you travel to Starlab once it's in place? Are you each interested in going?
100%, absolutely.
Yes, without a doubt, I would go in a heartbeat.
Yeah, I think day one on this project, I said something to that effect. So we all would love to, and of course, our goal is to make it as accessible for anyone. But there are going to be a lot of people that want to go up there. That's for sure.
Well, I think it's very interesting that people are, I think with space tourism, are now feeling like, wow, this is accessible. This is something that I perhaps could do. And perhaps I don't have to make a whole career of being an astronaut, but it's something that, I could participate in because it's relevant to research or something that I find of interest or something I want to delve more deeply in. So I kind of assumed you all would say yes, but I was just curious because sometimes people say, no, I'm really happy supporting and want to help advance this, but I don't necessarily want to participate because it is very challenging physiologically, right, to prepare, and all you have to go to even for a short amount of time. And there's a reason why the hyperbolic plane is called the vomit comet, right? That some people don't react well to microgravity or that kind of movement. That's absolutely fascinating. What are some advances that you hope Starlab will help make possible? Are there kind of things on your mind that you think about, that research that could take place here that are priorities to you that you think would really help advance humanity in some way?
Yeah, a couple things, and Dave and Ellie already touched on a few of them. But I think what is particularly important for us at Voyager and Nanoracks is agricultural technology, and for a number of reasons. Plants on Earth are going to have to adapt, and our food supply is going to have to adapt in a changing world as we have to feed more people, as weather patterns shift, and they will. the advances that are going to enable us to continue feeding people, making life on Earth sustainable. A lot of those will derive from ensuring that our food supply is more drought or sometimes flood resilient. And space and microgravity and a high radiation environment happen to provide a really good test bed for that kind of science. So I'm really looking forward to seeing what new agricultural innovations, what new strains of plants, what new watering systems we come up with on orbit. I think that's going to be a key area for us.
One other area I'd like to add to, in addition to the agriculture that I spoke to a little bit earlier and the physiological that I think we've all touched upon, one more manufacturing piece rather than scientific is additive manufacturing and 3D printing. And advances in those technologies will allow astronauts to be able to print whatever tools that they need. Maybe eventually be able to print modifications to scientific hardware, maybe even someday be able to print their own satellites to deploy off station. So there are a lot of really interesting advantages there for deep space applications and long-term human survival in space on the lunar surface, because you won't be able to get something back to Earth or from Earth very easily. So being able to have a more self-sustaining station or colony will be very interesting in the future.
Yeah, and I'll piggyback on that. In addition, I think another on the technical front, one of the things that we're really going to be needing to get folks to the moon and then onward to Mars is, we call them closed loop life support systems, regenerative life support systems. So I think the Starlab is also going to serve as an incredibly useful platform for folks to be testing out new systems that will help keep humans alive on these exploration missions, that won't require a constant resupply, of logistics to keep them running, similar to how many systems are in the ISS, which makes sense because that was always meant to stay in low Earth orbit, but we won't have resupply. So that's really an important opportunity as well that we'd like to take advantage of.
Wow, I'm so impressed. So you're all so accomplished. How did you get here? Like, if somebody's very interested in pursuing this kind of line of research or experience, how did you get to the current positions you're in? What are each of your stories around? Were you interested in space as a child? Is this something that you got exposed to at some other point in life and you took another path? Because you all have incredible command of information and background on this topic. So if you could just share your stories individually, like how did you get to where you are today?
Yeah, I'll start. I've been interested in space for as long as I could look up. And that's it's always been a really special part of my life. I've read more science fiction than I can shake a stick at. I grew up on Isaac Asimov's Foundation series. Glad to see it's being turned into a TV show now, so that'll be pretty cool to watch. And then I did nothing about it for most of my life at all. I went to school and I studied economics and communications, and then I worked at the State Department for about 5 years. I got to travel the world, which was really great. Don't have an engineering degree. I'm going to fess up right now. We've got a lot of great engineers on this team. And that's kind of, I want to make sure that as we talk about space stuff in the space industry, that we make sure that the way we talk about it shows people that they can get involved in so many different ways. You do not need to be an engineer to be close to space, to work on space issues. You can be a philosopher, an anthropologist, an artist, for goodness sake, a musician, any type of person with any interest. Space touches all of our lives in some really critical ways, and everyone should have something to say about it because of that. Now, I will say that we need more STEM graduates in America. We need more STEM education. We need those engineers. That is, I mean, they still make up a large part of our total employee base. They enable what we do. But for instance, my job has always been to look at the economy, to look at the market, to see what's over the horizon, to follow technology trends. And sure, I've read books about space, right? I'm not, totally on the outside. I've spent a lot of time and energy on these systems and learning about them from the best people in the world. And that's really once I jumped into the industry. But I will say that, voices from outside the traditional space industry, traditional engineers, right, are really important. Elon Musk was not an engineering graduate, right? He led a very circuitous life, and look at the cool stuff that SpaceX, for instance, is doing today. Look at the cool stuff Nanoracks is doing today. Our Nanoracks founder Jeff Mamber was not an engineer either. He was a New York businessman, and he had a business sense. He knew there was a market out there, and he surrounded himself with smart people to be able to do something about it. So we need more creative minds. We need more thinkers from other fields. It's only going to enrich our ability to access space, enrich everyone's experience of space, and allow us to communicate about it better and more clearly to all people for the betterment of all.
So much like Adrian, I've been interested in space since I was very young. I got the opportunity to go to space camp in Huntsville when I was in middle school, which was an incredible experience. I actually got the opportunity to go back to Huntsville for the first time since then, earlier this year. Things have changed. A little bit different, those two trips, but it was wonderful to be back. And I think I also read quite a bit of sci-fi. I also played probably more video games that were space related than I should have, and I think that contributed as well. But just like Adrian, I am not a technical person. I do not have a technical background. I studied international relations in undergrad, and one of the things that always really interested me about space as a domain is the interaction between countries and organizations. ISS is an intergovernmental project, probably one of the most ambitious intergovernmental projects ever, and maybe ever in the future as well. And so that piece really interested me. My immediate objective was to work overseas, and I had that opportunity for a few years right out of college. And then I basically just read as much as I could about space and reached out to everybody on LinkedIn who I could who was involved in space. Until someone was finally willing to give me a chance as an intern, and it was Nanoracks. And so here I am. And so my one piece of advice to people looking to get into the space industry, echoing Adrian here, STEM is absolutely critical, but there is room for anyone to bring their own unique perspective and their own unique talents to space, whatever it may be. We're growing, everybody, and there are more space startups every year, looking at all different types of technologies and angles for solving problems. And so every background has something that they can bring to the table. And my other piece of advice is just reach out to whoever you can, right? One of the things that I'm trying to do is to give back. Someone gave me a chance, right? Non-technical person trying to work in space. And so I'm trying to do the same thing. So I would say reach out to whoever you can, read as much as you can, and find some way to apply your own unique perspectives and talents to the space industry.
Awesome. Well, probably, yeah, similar to both Dave and Adrian, I've always been interested in space since I was young. I think the Kickstarter was when I was 9 years old. In third grade, I won a contest. Who could ask the best question to an astronaut in space. And I had the opportunity to talk to an astronaut on the space shuttle while they were orbiting overhead via ham radio. So I think that kind of started me off on my journey, along with my father, that's always been a big space nerd at heart. But similar to Dave, I also went on to go to space camp like many other space nerds. But then I kind of took a slightly different path, and I attended an aviation challenge, which was a new camp that they were offering at the time, and I had my first flying lesson there. And that really got me fascinated in flying and aviation as well. So for me, it's always been kind of a parallel path. So I decided to pursue the flying portion first. And so my background is more technical. I went to the Air Force Academy for college. I do have a degree in systems engineering. After college, I went on to pilot training and I flew cargo aircraft. And then I transitioned to fly the uncrewed aircraft that we have, MQ-1 and MQ-9 now. conveniently, well, folks know them as the drones. So I transitioned to that. That was a fascinating, having seen both sides of a crewed versus uncrewed operations and flight. During that time, I had the opportunity to work as essentially a flight director at our operations center with the UAVs that I was flying. So that was a great opportunity as well. I knew I always wanted to get into the space industry. So I made really a leap of faith in 2018. After 12 years, I transitioned off active duty in the Air Force and into the civilian sector. But one of the wonderful stepping stones that I had along the way was I had the opportunity to also participate in, down at Johnson Space Center, the Human Exploration and Research Analog program that they have there. And this was pre-COVID, mind you. I got to live inside a little habitat with 3 other people for 6 weeks, simulating an exploration mission. And, that was really giving a lot of scientists and researchers the opportunity to really understand, the psychological impacts and, test out a lot of experiments, before they get put up on the ISS. So that was a wonderful opportunity that then led me to my first opportunity at my prior space company, and that was designing inflatable structures. And I was a systems engineer, crew systems engineer. And I've always felt that for me, starting off as an operator, end user, if you will, and now, transitioning to the other side where you're on the engineering and the design side, I've always wanted to be the person to kind of help bridge that gap. Because oftentimes I've seen, human factors as not always taken into consideration as much as perhaps it should as we design these structures for people to use in the future. So that's very near and dear to my heart as well. And then, after my first company, I had a wonderful opportunity at Lockheed Martin to join them, worked on lunar rovers, all types of space habitation. And here I am now with the team. And I will say, while I did not always work in the space industry, I think for me, having at least a technical background and understanding complex aircraft systems, it's very analogous to a lot of spacecraft systems. And, more importantly, and this is kind of something I just want to stress to all the young folks out there, one of the important skills that I learned through my time in the Air Force really is working as a team and leadership skills. And, if you're a good team player and you're competent in what you do and you help others, you can achieve anything and folks will want you on their team. So I'm a pure believer in, I think in many regards, if you're the smartest person in the room, but you're not a good team player, I wouldn't want you in my group. So, so that's just something to put out there as well. But yeah, so, people come from all different walks of life. And as Adrian said too, we need folks with all different types of skill sets. Many companies now are looking to build, low Earth orbit stations. So we're really excited. So there's many opportunities out there for all the young folks that are listening. And, we invite you to come and join our team at Lockheed. We're going to need a lot of engineers, to help us make this dream a reality here in the coming years. So thank you.
Well, thank you all for being part of this panel today. I think something that you all share, and I think this is important for whatever you do in life, is to have passion, that you're pursuing something that you find fulfilling, you find interesting, that drives you in life. And it, of course, in space exploration, it requires people with all types of skills and abilities to ensure that a mission is successful. So absolutely, it's about teamwork. Well, I want to thank our panelists today. We've come up at the end of our time, and I'm so excited about this new endeavor with Starlab. We're going to be watching to see how this progresses. We look forward to having you come back once it launches, and we see how this project is rolling out. But you absolutely are advancing exploration and advancing science, technology, and innovation. And so we're thankful to you for all the great work that you do. I want to thank everyone for joining us today for this episode of the Thought Leader series at Space Center Houston. Please check out our website at spacecenter.org to learn more about the programs we have underway, and we look forward to having you join us for another episode.
Industries in space may sound incredible, but we who are working toward them know that most of the building blocks are already in place.
be a renaissance of in-space capability. So it really is partnering the A-Team with the A-Team.
It must be possible because all these people share with me that it is possible.